Today is lesson 1-2, ratios and proportions of unit number 1, algebra basics. Today's learning target is I can use ratios and proportions to solve problems. Ratios and proportions actually don't really pop up until we do, I want to say, our similarity unit. Yeah, I want to say similarity, which is not until the spring. But it's very, very important that we know how to solve these types of equations. So before we go into actually, doing some math, let's go over some definitions. What is a ratio? A ratio is simply a comparison between two numbers. So like, for instance, comparing the amount of girls versus boys in a room, or nickels and dimes in your pocket, etc. The ways we write it are A colon B, A over B, and A to B. All of these can be translated to A to B. So whenever you see the colon, we can simply just say A to B. The ways that are very common in geometry are this way right here and this way. A proportion, on the other hand, is a comparison between two equivalent ratios. We're going to really mainly be focusing on proportions. And the way that they're commonly written in this class is this right here. We typically look at them in this form, which looks intimidating, but I promise you it's not. So it's important to know that equivalent ratios that reduce to the same value. So what we're going to do is we're going to determine if each of the following pairs are equivalent ratios. It's actually pretty straightforward. All you're doing is you're just cross multiplying. So if I look, I have 3 over 5, and that's equal to 9 over 12. Let's see if they are equivalent ratios. So all we're doing is we're taking this number, and we're going to do 5 times 9. 5 times 9 is 45. And now I'm going to do 3 times 12. 3 times 12 is 36. These are not the same numbers, so we can say not equivalent. In my next example, I have 3 over 4, and I'm saying it's equal to 75 over 100. I'm going to do 4 times 75, and that's going to give me, I actually am not 100% sure what that's going to give me. I have an idea, but let's see. I'm going to do 4 times 75, and that's 300. Now I'm going to do 3 times 100, and that's also 300. So since I have the same number when I cross multiply, I can say I have equivalent ratios. Now my next example, I have 7 times 9. 7 times 9 is 63. Now I'm going to do 6 times 10.5, which is also 63. So I can say that these are equivalent as well. Challenge, create your own pair of equivalent ratios and explain why they are equivalent. This is up to you to figure out and you to decide. All you're doing is you're just going to make two fractions and then basically just cross multiply and tell me if they're equivalent. Okay? So cross multiplication. Cross multiplication is exactly what you just did right now, where you basically multiply your B and C and then your A and your D. So you're simply just doing this. And that's exactly how you solve these equations. So solve each of the following equations. Each will require the use of cross multiplication. So in our first example, we have 2 over 3 equals 6 over x. The first thing we're going to do is we're going to cross multiply. So I have 3 times 6, which is 18. I have 2 times x, which is 2x. And if I look, this is a one-step equation. I have to ask myself, how do I get rid of the 2 attached to my x? And I do that by using division. So I'm going to divide both sides of my equation by 2. 18 divided by 2 is 9. So I can say x is equal to 9. And that's my final answer. Question number 2. I have 5 over 15 equals x over 10 plus x. So what we're going to do is we're going to cross multiply. And when I cross multiply, I get 5 over 15 equals x over 10 plus x. So I'm going to cross multiply. So I get 15 times x is 15x Now I cross multiply my 5 with my 10 plus x, but you have to be very careful with this one. You're not doing 5 times 10, you're doing 5 times 10 plus x. So we're going to rewrite this as 5 times 10 plus x. So now I have to distribute. So I'm going to distribute my 5 to my 10 and my x. 5 times 10 is 50, so I have 15x equals 50 plus 5x, because 5 times x is 5x. Now I need to ask myself, how do I get my variables on one side? Because if I look, this just becomes like a two-step equation. So I need to get this 5x to the left-hand side of my equation. So to do that, I'm going to subtract 5x from both sides of my equation. 15x minus 5x is 10x. And that's equal to 50. How do I get rid of that 10? I'm going to divide. So I get x is equal to 5. Question number 3. I have 3 over 10 equals x plus 2 over 8. I'm going to cross multiply just like I've been doing. So I'm going to do 10 times x plus 2. Remember, it's not just 10 times x, it's 10 times x plus 2. And now I'm going to do 3 times 8. 3 times 8 is 24. So I'm going to distribute that 10 to my x plus 2. 10 times x is 10x. 10 times 2 is plus 20. And that's equal to 24. I'm going to subtract 20 from both sides of my equation. I get 10x is equal to 4. And then how do I get rid of my 10? I'm going to divide by 10. So divide both sides of your equation by 10. 4 divided by 10. I'm actually going to show you a trick on the calculator. I'm going to do 4 divided by 10, hit enter, and that just becomes 2/5. So I don't really want to see a decimal, I actually do want to see a fraction. So I'm going to say 2 over 5. And that's your final answer. Let's go on to our final question. For this one, we're going to cross multiply our 3 with our p plus 6. So if I look, I have 3 times p plus 6, not just 3 times p. So I'm going to do 3 times p plus 6, and that's equal to 4 times 8, which is 32. So I distribute my 3 to my p and my 3 to my 6. I get 3p plus 18 equals 32. My next step is to subtract 18 from both sides of my equation. So I get 3p equals 32 minus 18 is 14. And then I have to ask myself, how do I get that 3 to disappear? I divide by 3. So I'm going to divide both sides of my equation by 3, and I get p is equal to 14 over 3. And that is your final answer. If you have any questions, email myself or Miss Colorundo.